So today we will study about the Khosla'S method of independent variable for determining the pressure. So this is also called as a method of independent variables. So considering total three simple profile, these independent variables has been evaluated. So what are those three simple profile? So let me evaluate that with a simple diagram. So the first one is the straight horizontal floor of negligible thickness with sheet pile on the upstream and downstream side. So let me draw the picture, then it will be quite easier to understand this statement. So here, as you can see, this is a straight horizontal floor of negligible thickness with a sheet pile on upstream side. Okay, I am just showing this about the condition of upstream side. So this is D, this is B. Okay, continuing. So this is representing the upstream side part. So similarly, by drawing the downstream side part, I will show you the same labeling. So similarly, this is the downstream side pile, where this is the B, this is D. Okay, so now by just considering this method of independent variable, we will evaluate the pressure point at the location of upstream side pile and downstream side pile. Mean, in which point does this pressure is occurring, or we will evaluate the pressures at this point, and at this point, or in downstream case at this point, at this point, at this point. So in Blick's theory or assumption, in the outer side face of sheet pile or in the inner side face of sheet pile have not been clearly explained. So but in the Khosla'S theory, this outer face or similarly in the inner face, this pressure point has been evaluated very clearly. So say we are just naming this point as, suppose this is E1, this point is C1, this one is D1, and similarly this point say E2, this one let's just place this as E3, this as C3, and this as D3. Why did I put this as 3? Because I also have to draw the intermediate pile as well. So I will label that intermediate pile point as 2. Okay, so let me draw it. So this is the intermediate pile. Okay, so in this case, that the very same pressure will remain exactly the same. This will be E2, this will be C2, and this will be D2. So but in this case the breadth will be different in this face and in this face as well. Say this is B1 and say this is B2. Okay, now for these three categories, for upstream side, for downstream side, and for intermediate side pile, we will calculate the pressure at different points. Okay, here it is for 1 2 3 4 5 6 7 8 9 points we will calculate the pressures. So here the equations are provided as such. For upstream side pile, first we will actually just imagine this picture. This water will first try to move in this manner, right? So this will come in this way and then go in this way, and this will go next to the intermediate pile. Then it will again come over here, and then it will go, and then it will go to the downstream pile, and it will similarly go in this manner, right? Okay, so now we will calculate the equation. We will now write down the equation from which we will calculate this pressure percentage. So first of all, for this will be similar for the upstream and downstream side. Okay, this formula. So this is phi E, mean the pressure percentage at E point, mean in this place and in this place as well. So we have to calculate this E for these two categories, mean for downstream side and upstream side, in a different way, but the formula will be same. So it is phi E divided equal to 1 by pi cos inverse lambda minus 2 by lambda. So from which equation this is coming from? This is coming from, actually, this is the origin of this formula, which is P equal to H by pi cos inverse 2x by B. This formula was evaluated by solving the equation of streamline function and pressure function in high parabola equation and ellipse equation. Why this high parabola and ellipse equation are coming? Because from the flow net we will get this equation, substituting all the term, we will get this equation, and this equation is actually the origin of this, where phi is nothing but P by H. Okay, so this is phi. So similarly, phi D, it is 1 by pi cos inverse lambda minus 1 divided by lambda. So now here, what is lambda? So lambda, we will get the value of lambda by solving this equation. This is lambda equal to 1 plus whole root over 1 plus alpha square divided by 2. So now here is another unknown terminology. So what is alpha here? So alpha here is nothing but B by D respectively. Okay, so by knowing B, D, we will get the value of alpha, then we will put this value here and get the value of lambda, and then we will put the value of lambda here and we will get the value of phi E and phi D corresponding for upstream side and downstream side. Okay, but for, so now there is another equation, which is phi C1 equal to 100 minus phi E and phi D1 is equal to 100 minus phi D. So what is here? Individually only D and only E we have came across with E1, E2, E3, right? D1, D2, D3. So what is here? The only E and D. So actually here in book, in this way this is given, but for simplicity I will put the value of here. This will be 3 and this will be 3. Why? Because please look at this picture. So here, in the case of the total pressure, as you can understand that the pressure at this point and the far end of the downstream at this point, so this is C1 and this is E3, right? So this C1 and E3 will always be the total pressure. So what is the total pressure? Which is 100% pressure. From this point of upstream side, mean in upstream side sheet pile inner face from this point to the downstream side sheet pile outer face this point, the total pressure will be the summation of the total pressure will always remain 100. So in the similar way here D1 and in this point D3 the total pressure of this 2 point will always remain 100. So here you can see, so this phi C1 plus phi E3 will be 100 and phi D1 plus phi D3 will be equal to 100. So if we will be able to calculate one of this reading, so we will automatically find out another value. Okay, so this is another equation to be established. Now this is for upstream side and downstream side pile. Now we will write down the equation of the intermediate pile. So for intermediate pile similarly there is 3 point, okay, but in this case the scenario is somewhat different from upstream side pile and downstream side pile. Okay, so here as you can see the difference is the different breadth from the distance of intermediate pile to the upstream side pile and the intermediate side pile from to the downstream side pile. Okay, so the equation will be here for evaluating the pressure at point E2. So it will be phi E2 equal to 1 by pi cos inverse lambda 1 minus 1 divided by lambda. Phi D will be, phi D2 will be 1 by pi cos inverse lambda 1 by lambda, and phi C will be 1 by pi cos inverse lambda 1 plus 1 divided by lambda. So here see, you can observe that there is 2 lambda. So what is the purpose of having there is 2 different lambda? So as I have mentioned, this is actually due to this 2 breadth. So what is the actual scenario? So here lambda will be calculated by solving the equation root over 1 plus alpha 1 whole square plus 1 plus alpha 2 whole square divided by 2, and similarly the lambda 1 will be, this is exactly same, just only it will be the minus. So 1 plus alpha 1 whole square minus 1 plus alpha 2 whole square divided by 2. Okay, so now from where we can get the value of alpha 1 and alpha 2? So alpha 1 is nothing but B1 by D and alpha 2 is nothing but B2 by D. So by knowing this B1 and B2 and D, we will be getting the value of alpha 1 and alpha 2, and from this we will be getting lambda and lambda 1, and from this corresponding phi E2, phi C2, phi D2. Okay, so just observe one thing in order to memorize this equation in simple manner. Just see here, the water is going in this manner, right? So the pressure will be reduced in this progressive way, right? So in the pressure will be higher at point E2 than D2, and the pressure will be higher at D2 than C2, right? So just look at this factor here, lambda minus 1 divided by lambda. So this is our E2 point. So what is our next point? This is D2. See, they have just simply added 1 plus 1 with that. So if we plus 1 this, it will get nullified. So we are getting this. Again, if we next for next point, see, they have added plus 1. So this is the gesture of the formula. Similarly, just look at the previous one. So for this, it was here -2, then they have just added +1 and they got this -1. So in this point they are getting the lesser pressure. So this is the total description of the equation. So in this manner we are going to solve the problem. So first all, we will calculate the pressure percentage at individual point. See, this pressure percentage can be evaluated in this analytical process and in a graphical method as well, but we will first calculate it in an analytical method, then we will make some correction. So then what are those correction? So if you just observe here, so the correction will be divided in 3 categories. Well, the first one is correction for mutual interference of piles. Next correction will be correction for thickness of floor, and the third one will be correction for slope of the floor. So just look at this picture. So there will be some correction in pressure due to the mutual interference of this intermediate pile over this upstream pile and this downstream pile. So there will be a certain correction we need to make, and the next correction will be the thickness of floor. As you can see that we have calculated all the pressure percentage by considering this horizontal thickness to be negligible. See, there is no T we have considered here. So but in practical scenario there will be a certain amount of thickness. So by considering that thickness we will rectify or correct our pressure percentage as follows. And if the slope of the floor will be given or provided in a question, then we will definitely correct this as well. So thank you for listening. I will continue the next part of this equation, I mean in a practical problem. I will cover it in my next video.